Welcome back. Today we're going to go over another step within the process of what I've discussed in the last couple of videos about the Venturi effect and the port tuning of a typical engine. So whether it's a early 1900s variation of an engine or a 2025 variation of a newer gasoline or petroleum powered engine, the Venturi and the air control into the engine obviously determines the amount of power, the fuel efficiency, so on and so forth. And there's been a disconnect between the engineering aspects of individuals during the 1940s and 50s to the variation that we have now within the technicians and electronics that are equipped on our vehicles. Now, this is going to be just a little bit of my own personal perspective. You don't have to agree with this whatsoever. But if we go back to the 1940s and 50s, what was the United States necessarily involved with the technology, especially during the 1940s? Okay, many of you are going to probably think, what's going on with this? This is way before our time. World wars caused the countries of our world to put a lot more emphasis on technology. If it wasn't for the scientists of the United States designing and preparing the atom bomb, our countries, the world of the globe right now would be completely different. Now, we have to think back to the 1940s. They didn't necessarily have computers in order to help them design very intricate devices. And without any kind of concern for security, individuals created the sphere that ultimately became the atom and what we know today as being the nuclear bomb. Now, we have evolved to the point within the human civilization of where technology isn't about the mechanical composition of elements and how they react. It's getting down to the computer and AI technology advancing in our population. Now, with that being said, we're going to be talking about a portion of the intake system within port tuning that many don't really give a whole lot of credit. Okay, we're going to be talking about carburetors today. Now, a carburetor has a sole purpose of controlling the amount of air that the engine can consume and mixing it with the proper ratio of fuel needed to create power. Now, in a previous comment, when we were talking about the Venturis, I explained that the larger the carburetor you have, the more power you're going to make, especially on the engine dyno, where the function of the engine is to provide maximum airflow as the calibration of the dyno machine allows the engine to spool up. Now, in those instances, a larger carburetor will always show more power because the carburetor creates a resistance within the intake system. Now, the carburetor also causes a resistance to reversion. So depending on the design of the intake, reversion will also move backwards through a carburetor, affecting the different fuel circuits and the venturi of the carburetor. And somebody mentioned that when we're comparing different carburetors, a down leg booster style flows more than anything else. That could be farther from the truth than I've seen in a long time. Now, we can go back even to the 1960s, 1970s era when the engineers from both General Motors, Chrysler, and Ford were way, way ahead of their timeline. If you think about it, the intricacy created in the carburetors of the 1960s and 70s were much more advanced than the typical carburetor prior to that. Carburetors prior to that were basically just a excuse me, I'm grabbing it right here. Were very simple. to the point where it just allowed a opening that would expose the air through, and the bowl held onto the fuel, and you only had one jet circuit. So you had two circuits within the system. When the butterfly was closed, there was the idle mixture circuit, and then wide open, the vacuum being pulled through the venturi, depending on how fast the velocity or how much air was going through, would be able to suck in the amount of fuel to create the proper air-fuel mixture. In the 1960s and 70s, even prior, a little bit to the 1950s with mechanical fuel injection, the carburetor was a marvel of technology. The amount of intricate circuits within the carburetor systems, again, was also designed around that, that idle to approximately 5,000 RPM range. Didn't matter what size engine it was. Now, there's obviously multiple different types of carburetors created, but if any of you have ever had your hands on the General Motors Quadrajet or equivalent from any of the other manufacturers, and have taken it apart to actually observe all the different circuits within the system, they were extremely advanced. Now, think about the science behind creating all of those intricate pieces and casting them out of whatever material, whether it be cast iron or a softer metal, to the tolerances where it can be used on a high-performance engine without the assistance of a computer. Okay, the engineers of the 1950s, 40s, 50s, 60s, and even in the 70s were light years ahead of the technology that we're depending on artificial intelligence to replace. So while today it takes a computer that can monitor and adjust the systems, the fuel and air systems within the engine, and even the timing of both the camshafts and the ignition, happen in a blink of an eye, faster than what most individuals can think of or respond within their foot pedal. The 1940s, 50s, 60s type carburetors, they did it faster than what computers can today. A computer has to get a sensor reading and then adjust all of the components from that point. And yes, it happens very fast. A carburetor did it on the fly. It was continuously monitoring the air and fuel delivery within the system. And the older carburetors, their venturies were fairly short, and from the air inlet side of the carburetor to the point where it's on the back side of the butterflies, all of that fuel monitoring occurred in approximately 3 inches with multiple fuel circuits built into that area. Now, recently, over the last year and a half or so, the Edelbrock VRS carburetor has come out, and I've noticed that multiple YouTube channels are doing reviews on the newest models. They just released the 950, I believe it is. And in every one of those instances where guys have supplemented the VRS carburetor for a Holley or a limited circuit carburetor, the VRS is capitalizing on power. Now, they have the same amount of fuel circuits as any typical Holley or aftermarket modern day carburetor. But the amount of engineering that have gone into the VRS is no more advanced than what was in the Quadrajet of the 1950s and 60s. Okay, so the advantage to it is within very small increments. Now, going back to the typical race Holley that you may have been accustomed to throughout the decades, most of your most of your double pumper carburetors, they're equipped on all 4 corners with the exact same kind of fuel circuitry. If you had the secondary, vacuum secondaries. They had two separate fuel delivery systems to adapt to whatever RPM range or load that was being put onto it. Throughout that, multiple different boosters have been used within the 4-barrel type carburetor. Now, if we look back at the older carburetors with, from the 40s, 50s, 60s, 70s on, they had at least 10 separate fuel circuit systems built into the carburetor within that 3-inch venturi. Now, to simplify things, when Holley first came out, or even some of the earlier edition manufactured carburetors from Ford, Chevy, or Dodge, they were trying to eliminate all the different fuel circuits for the simplicity of tooling, to minimize the amount of casting that was required. It wasn't necessarily for performance, because your typical 1960s variation of the muscle car carburetor could do it all. Okay, so even a 650 or 700 CFM carburetor could be directly transplanted between a 4289 to the 460, and it was able to adjust itself precisely to the cubic inch of the engine with very limited amount of adjustment needed. Normally it was just the idle mixture screws that needed adjustment at idle for that carburetor to function correctly, because built into the design, the original engineering of the carburetor, it was multifaceted. It could handle everything within the manufacturing world at that time from Ford. Quadrajet was also used on things as small as the 305 all the way through the 454. Even Cadillac, a department of GM, even their large 500 cubic inch Cadillac, they used a Quadrajet carburetor with only approximately 30 CFM more than the carburetors are used on every one of their other V8 engines, because the carburetors were capable, more than capable, of adjusting the air and fuel into the engine with precision. Now with the aftermarket switching over to more of the Holley, it's become more consumer friendly. Most of your consumers cannot engineer or adjust a carburetor specifically enough to maximize its efficiency. By reducing the amount of fuel circuits, allows the consumer to be able to adjust that carburetor in ways that they can understand. Okay. Now, even with the simplified version of the Holley carburetors, a lot of individuals still struggle with tuning them. Okay, it's as simple as that. It is the advanced, educated individuals that have created things like fuel injection in the modern day cars, and the computers that are engineering, or computers that are controlling our fuel systems. Okay, so with the previous quote, when I opened this up, somebody had said that the down leg boosters, or dog leg boosters, however you want to call them, they flow the most. No, they don't. Now I'm going to explain why. Behind me I have 3 drawings of your typical booster found on a Holley, Barry Grant, or even the brand new Edelbrock VRS carburetors. You have your down leg. Now your down leg booster, hence its name, it places the venturi in the highest velocity, or the cross pinch point of the venturi of the carburetor. Because of the mass of the actual booster, it fills up the area of the venturi. It actually reduces flow. Now factory, even for instance, like the earlier Ford variations that used a Holley, even on the 460, they used a straight tube single exit booster like the down leg, but it was just straight. And this booster was mounted further up the venturi to where the material or the mass of the booster was not in the highest flow area. It did not cause as much of a restriction. I have an example here for you guys that might be trying to debate me right now with what I'm trying to say. Because the Edelbrock VRS carburetor is a copy of 3 other manufacturers that have existed in the last 40 years, and they have taken the benefits from each one of those manufacturers to create the VRS. Okay? Now, with the different booster designs, there's the annular booster. It looks very similar to the factory style straight tube booster. The differences between the down leg and the factory style, they use one large outlet for the fuel to be delivered into the ventries or the velocities within inside the booster itself. So we have the ventry of the carburetor main body, and you also have a ventry inside the perimeter of the booster. The straw portion, or the fuel delivery section of that, is in the high velocity portion of the booster. Now, both these designs are obviously to contribute the amount of fuel for the air being consumed through the carburetor, monitoring the amount of air flow, and equalizing the amount of fuel that's being added to the intake charge in order to get the most efficiency out of it. Now, we're not going to talk about from the bottom of the carburetor through the rest of the engine. We're not going to talk about that in today's video. But the third variation of booster out there, called the annular booster, instead of using one exit point for fuel, the fuel is actually delivered into a hollow body variation of the booster. So the exterior perimeter is actually hollow. The fuel is delivered into the area, and in order for the fuel to be introduced into the air column, there's much smaller holes around the perimeter of the booster. Now, it's also mounted higher in the ventry of the carburetor, like the factory manufactured Holley carburetors of the previously mentioned 460 type carburetor. Now, throughout the years, we have noticed obviously the fuel consumption by carburetors that have a down leg booster is very inefficient, typically only used for racing applications, where fuel economy is not a consideration. It's about maximum power, even with the restricted classes. So again, adding the fuel and then waiting for the air to catch up. Okay, now again, that causes some droplets to form within the intake system, and it's bad for power. But once you have lifted your foot a little bit, it transitions between a rich mixture to a lean mixture. So in circle track racing, limited to say 500 CFM, it's a very strong, rich mixture coming out of the corner to accelerate down the straightaway. But you'll notice that just before the corners, going into the corners, when an individual starts to lay off the throttle, it becomes a lean mixture, but they have the fuel already there. Okay, by closing the ventries, you're actually allowing the rest of the system that is being built up, that's a rich mixture already in the intake system, it's cutting off any kind of airflow and fuel delivery matching to that. It's running off the fumes left over in the intake system. And when that leaner mixture comes in, the car surges forward. Okay, now going to the factory style horizontal booster mounted higher in the ventry, depending on the actual opening or the design of the ventry inside of the booster itself, can dictate of the fuel ratio that's being mixed in, no matter where the position is of the throttle. The annular booster initiates fuel mixture in a much finer consistency than either the down leg or the factory style horizontal tube design. Now, I want to take you back to the 1980s, 1990s, when the manufacturer Barry Grant entered into the carburetor fuel delivery industry. Sorry. Up to that point, Holley had they own the aftermarket. All right. Obviously, certain manufacturers chose to run Holleys over their factory, highly engineered variations like the Quadrajet or the thermal quads. They were being replaced by Holleys because of ease of adjustment, because your standard mechanics that you were taking your vehicles in, even at the dealership, they were not at the level of understanding as the actual engineers from the manufacturers. Okay, again, realizing the circuitry of a carburetor during the 1950s and 60s, which was far beyond the typical understanding of the actual vehicle owner or your standard mechanic. Okay, that's not saying that we had the industry-wide that it was very dumbed down. It was the simple fact that when you were working on vehicles, especially if you were a privately owned shop, you had to work on Toyotas, you had to work on Chevys, you had to work on Dodges. You didn't have the specific training to understand the engineering from every one of the manufacturers to be able to go in and adjust their carburetors, open up this galley or plug off this hose. The Holley variation reduced the amount of fuel circuits into it to where every mechanic, and easing the adjustability at the racetrack for racers to adapt the carburetor to be able to function. Okay, so while individuals are doing reviews of the newer carburetors, realize they're a simplified version compared to what the engineers did in the 1940s, 50s, and 60s. It's for mass production, ease of creating the device, and allowing the customer, the user of that device, to be able to adjust it with less education. Okay, so when I see individuals, again, it's intended this way, and believe me, I am not to the level of where I can understand the engineering of even the 1940s and 50s of carburetors. Again, I know how to just adjust the things that they intended to be adjusted by the consumer. I cannot understand all of the fuel circuitry in a Quadrajet. Okay, I'll admit that. And I've been doing this for 30 years and I still am not at that level. And I actually have an engineering degree. Okay, so they were farther advanced. But now individuals doing reviews on these newer carburetors like the Edelbrock VRS, VRS. They're swapping it into their cars and being like, oh yeah, it makes more power. With some of the latest videos about the new 950 that has just been released, they're complete dogs. And they haven't, the consumers are having a hard time understanding why they're having difficulty tuning the carburetor. On a dyno, a larger carburetor that is only functioning at wide open throttle is going to show additional horsepower. But the carburetor is not designed to operate with the rest of the components of the engine. So when you put it into the chassis of a vehicle, apply the load of the transmission and the weight of the vehicle, that large carburetor is worthless. It's a dog, and you will be disappointed with your purchase. So again, going back to the video of 1 million people are being led down the rabbit hole with some of the newest technology and marketing for aftermarket components. That has always been the case. For the last 2 decades, we've had TV personalities marketing for products, whether it be cylinder heads, carburetors, or intakes, pushing you towards one manufacturer. Okay, and I'm not going to mention the name because of sales, simple sales. Realizing that other manufacturers and other performance pieces within the aftermarket were 10 times better. Okay. Now, told you guys I had an example here. Now, the downlink booster type carburetors, your double pumper Holleys, were typically used in performance applications, whether it be a hot rod, drag racing, or circle track racing. They were not necessarily intended for the best fuel economy. But once you get on the street, okay, it's a totally different story. Now, during the 1980s and 1990s, when Barry Grant started getting introduced into the technology of fuel delivery. They were working around the original patents owned by Holley. So they couldn't duplicate everything exactly the same, but they were very similar. By the 2000s, 2004, 2005, Barry Grant was at the point where it was the peak technology within carbureted systems. But with the introduction of fuel injection during the mid 80s from all the manufacturers, carburetors were not drawing as much attention as the new fuel injection was. So their sales were down, even though they spent millions of dollars into research and technology into optimizing carburetors. From a 450 CFM street Demon carburetor all the way up to their 1350 Dominators. Fuel systems, fuel filters, fuel pumps from Barry Grant were the ultimate performance pieces that you could add to your engines. In the late 2009, 2010 era, Barry Grant started going belly up. They started experimenting into different fuel delivery systems, whether it be the inline 4-barrel carburetor that required a specific intake because it did not have the same bolt pattern. Again, they stuck millions of dollars into research and development, but they spent too much money on research and not enough onto manufacturing to be able to replace the numbers required to make profits. And by 2012, Barry Grant was basically bankrupt. Now, the ideas lost from Barry Grant have been adopted by Edelbrock. Okay, so the Edelbrock VRS carburetor is actually, believe it or not, is actually a Barry Grant carburetor. If you look at the ventures of the VRS carburetors, they actually mimic the Dominator carburetors created by Barry Grant. Hence, the Demon carburetors, you notice that these are the horizontal boosters mimicking the original factory engineered variations, but on all four corners, even though this is a vacuum secondary carburetor, they're using the annular boosters on all of their street oriented carburetors. And you notice the opening in the primary ventures compared to, the primary ventures compared to the secondaries. These cause more restriction than these. These will outflow a down leg booster bar none. Now this is the 525 Street Demon vacuum secondary. Okay, a typical 4-barrel, equal venturi or equal butterfly sizes, and that is capable of running anything from your 289 through 460 in the 1,000 to 5,000 RPM range with exact or precise precision with fuel delivery. And when it comes to performance, even though it's rated at 525 CFM, it will outperform the typical 650 Holley. It will provide a better fuel delivery system that's more accurate throughout the RPM range. And even though it's only rated at 525 CFM, it actually flows 600. But it gives you more precise fuel delivery throughout the entire RPM range. Now, they had their Street Demon. This is the Road Demon. They had their Street Demon, which was the size up, and they go all the way up to the 1350 Dominator Race Demon. With variables and variations within those carburetors to where it allowed the consumer to change every component in the carburetors, including the ventures. So with the same main body of a Barry Grant carburetor, you could change your ventures from as small as a 600 to as large as a 1,000. And it also gave you the capabilities as one of the first manufacturers that gave the consumer the capabilities of changing the boosters by having a threaded portion on the both side of the boosters. Holley, everything was cast and drilled out for specific application. Again, for the average consumer to modify the carburetors for a race, you had to get the different catalogs. You had to order the Holley rebuild kits. That might have included different jettings or plugs or drill bits to open up the air fuel mixture galley, so on and so forth. Barry Grant and the Demon series allow the capable consumer to do all the adjustments themselves, including all of the air bleeds. The precision and components for multiple years up until closer to the end of Barry Grant going bankrupt, their machining practices were even held to a tighter tolerance than what Holley was. Now, this 525 Street Demon, even though it has multiple different circuits built into it because it's a vacuum secondary, it is still nowhere on par with the earlier 1940s, 50s, 60s, and 70s fuel delivery systems that the manufacturers put on their engines. The amount of technology and the ability to adjust on the fly to meet the demand of the cubic inch and the performance of the package is not in the same category. I will go to the extent, many of you may disagree with this, no, the Quadrajet carburetor used by GM and a few other manufacturers throughout the years will do a better job of providing a correct fuel ratio mixture of any of the engines it's applied to than what fuel injection can. It will do it faster and it'll do it more accurate. Technology from the 1940s. Okay, going back to the creation of the atom bomb. We still have scientists in the world today, leaders of governments in the world that cannot figure out how to engineer nuclear power. Okay, war causes humanity to advance in technology. When fuel injection was first being introduced into the automotive industry of the 1980s, 1985, 86, so on and so forth, with the Ford 5-liter to the GM TPI systems, by 1990, we started working the bugs out of those systems to where they were very efficient. They didn't flow a whole lot, but they were very efficient to allow us to have performance and fuel economy within the same package. What happened in 1990? Okay, again, that technology was military technology. The advancements of technology like the Abrams tank, okay, the engine platforms used in the Abrams tanks were turbine engines. A recent video, again, for those of you that watch Uncle Tony's Garage, he has mentioned all the different engine designs throughout the decades, whether it's a turbotronics axle to direct injection into a turbine to spin as an engine. The technology is already being used. It's not something, again, going back to the compressed air used in some of the more experimental amateur drag racing vehicles. The question has come out, why isn't the turbine being used, or why isn't fuel injection being used in that? It is. Both helicopters and tanks are using the exact same direct injected turbine to propel them. Okay, replacing the typical push rod diesel engine previously in tanks has been replaced by a turboprop airplane engine to propel a 60-ton tank to over 60 miles an hour. Okay, so the technology is already being used. It's being phased out and being replaced by more electronically controlled devices. Again, that's not necessarily advantageous to our country during wartime. Who's going to be in the middle of Saudi Arabia or in the middle of the Middle East on a 120-degree temperature day and take some armament and expect an individual to get out and mechanically fix it? You can't. The computers cannot replace the mechanical engineering marvels of the past. So, carburetors still have a place in performance. Depending on the level of performance that you're trying to achieve, the limitations of the earlier carburetors is within the capable airflow that they can supply. But you better be in the mountain motor range of cubic inch or spinning a small block at over 8,000 RPM before you ever exceed the performance capabilities of the earlier quadrajets, thermal quads, or the Barry Grants with the adjustable ventries and the Demon carburetors. Okay, the newest Edelbrock VRS carburetor is just a Barry Grant carburetor with a new manufacturer's name on it. It's that simple. Okay, again, the VRS Edelbrock carburetor is being introduced approximately 10 years after Barry Grant went bankrupt because of the patents held. 7-year patent extension right. 7 years from now, we'll see another manufacturer of some sort come out. If, obviously if petroleum fuel is still being used, we'll find another manufacturer that creates its own design and entity within the carburetor. And it's to include all the benefits of all these carburetors that have gone back to the 1940s. So with that, the most accurate 4-barrel carburetor in modern day consumer friendly products like a Holley, Barry Grant, or the Edelbrock VRS is going to be equipped with a annular booster for both fuel delivery and air fuel ratio, and the least amount of air restriction out of the booster designs. It's that simple. If you want to get the most efficient power production and fuel economy out of your car, you're going to be going back to the original Chrysler, Ford, or Chevy, GM designed carburetors of the smog era. Okay, the 1970s. The amount of emphasis put on fuel economy and power was achieved from the early 1970s through the end of the 1970s. The maximum performance that you could get out of the factory carburetors actually came in the, I believe it's 850. Yes, the 850 CFM rated. Excuse me, jets are distracting me. Quadrajet used on the Cadillac V8s of the 1970s. It flows approximately 100 CFM more than the other variations of the Quadrajet. It was equipped on the 472 and 500 Cadillacs of the 1970s. Power, torque, and fuel efficiency. Nothing that any of the newer carburetor manufacturers can make claim to. They don't cross directly over. They have to be adjusted by the consumer or by the user to precisely fit the cubic inch or the performance level that the engine is designed for. The factory designs, unbolt them, set your idle mixer screws, and run with it. So with that today, a little support from our engineers, the old baby boomers or even older, to the point where, give them credit, they did it without the assistance of modern day computer technology. where we today, even the technicians today, are arguing about what component is failing or the tuning of an engine, even with computer assistance. The gentlemen of that era saved our country in weaponry and our daily modes of transportation. Have a good one.